business mathematics and statistics. I don't know how many of you were present in my last class, but as I promised last time, that I will be starting today's session with the application of once again the basics of what is how the two matrices are multiplied. Is the slide visible to you?
Yes, sir.
You can see the slide now?
Yes, sir.
Okay, fine. Now, this, now see, and I request every one of you to have a piece of paper and a pen with you, because this is mathematics. You have to perform it simultaneously when I'm discussing things with you. So here you can see that there are two matrices to be multiplied. This is the very basic of multiplication of two matrices, because as far as matrix multiplication is concerned, it's not at all required that the order of both the matrices should be same. Here you can see that there are three columns in the matrix A, and there are three columns with three rows in matrix B. When we are supposed to multiply, we have to keep one thing in mind, that number of columns in first must be equal to number of rows in the second. In the right side of your screen, you can see that there is 2 cross 3 and 3 cross 3. Simply by looking at the order of the matrix, we can identify or we can calculate that what will be the order of the resultant matrix. These are the two extreme numbers. That is 2 by 3. That means our answer will be a 2 by 3 matrix when we are multiplying a matrix of 2 by 3 order with a matrix of 3 by 3 order. Now the question arises, how this multiplication takes place. You can see that this is the first element and this is the first element of the second matrix. We are going to multiply 1 with 0 plus 3 with 5 plus 5 by minus 1. You can see over here it is written, that is C11. Then we come to C22, C212, C1 and 2. Now we will be multiplying 1 by 1 plus 3 by 3 into 2 plus 5 into 2. You can see over here it's written. Then C13, C1, 3 is this one. 1 into 2 plus 3 into 1 plus 5 into 1. Here you can see. Then C21, C21 is from this. Okay, then comes your C22, C2 and this column. 5 into 1 plus minus 1 into 2 plus minus 1 into 2. You can see over here. Then comes C23, C2, 3. 5 into 2 plus minus 1 into 1 plus minus 1 into 1. You can see over here. Then we are going to get these numbers over there. The order of the matrix will be a 2 by 3 matrix. That means it will be having 2 rows and 3 columns. This is the order by which you will write your answer. By taking these numbers from here, you will place it C11, C12, C13, C21, C22, C22 and C23. That means this is a matrix of order 2 by 3. If any one of you during the discussion has a problem, just let me know so that I can clarify up your query. Yes, what is the issue? Am I audible to you?
Yes, sir. Yes, sir.
Now, again see, if we have matrix of 2 by 2 order being multiplied by a 2 by 2 order matrix. So here you can see that A is this 2 by 2, this is B 2 by 2. How we are going to multiply? This 2 into 1 plus 3 into minus 2. Okay, so this is 2 minus 6. Then this row and this column, 2 into minus 3 plus 3 into minus 4. This one. Third one is this row, this column. Here it is. Then this row, this column. Here it is. That means you have to remember the order. You have to multiply taking these terms
Sorry, sir,
being
I have a
multiplied by.
question.
Yeah, what is the question?
Sir, no, sir, please.
Now, we are, since this is a 2 by 2 matrix and this is again a 2 by 2 matrix, so here the answer will be a 2 by 2 matrix. You can see over here, this is a 2 by 2 matrix. Here are some more examples of matrix multiplication. Here we have a 1 by 2 matrix being multiplied by a 2 by 1 matrix. That means its answer will be a single element. That means 1 by 1. 1 by 1 means a single element. This is 1 by 3 matrix being multiplied by 3 by 1 matrix. Again, we will get a single element. Here you can see the answer. Now the question arises how this 56 came. 2 into 5 is 10, plus 3 into 6 is 18. 18 plus 10 is 28, plus 28. 7 into 4. 28 plus 28 is 56. That means a single element. Now we have a 2 by 2 matrix multiplied by a 2 by 2 matrix. The answer will be a 2 by 2 matrix. Now here we have 2 by 3 matrix being multiplied by 3 by 2 matrix. That means its answer will be a 2 by 2 matrix. Here we have 3 by 2 matrix being multiplied by 2 by 3 matrix. That means its answer will be a 3 by 3 matrix. These are the different forms by which multiplication of matrix is performed, and straight away looking at the order of the matrix which are being multiplied, we can get up the answer. That means answer in the form of the order of the matrix. Here you see, again I'm telling you, I'm discussing that how this multiplication is done. You can see a 3 by 3 matrix being multiplied by a 3 by 3 matrix. Now the question is, as I told you, multiplication has to be performed in this order. This into this. That means A into J plus B into M plus C into P. That means this will be your first element. Second column will be this element, these three being multiplied by these three. That means the order will be AK plus PM plus CQ. Here you can see that is the second element. Third element, this row being multiplied by this column. That means A into L plus B into O plus C into R. Here it is. Similarly, for second row, these elements have to be multiplied by these elements. Then these elements by this. Then this by this. This is the second three elements of the second row. Similarly, the third one. This being multiplied by this. And these three being multiplied by these three. Here it is. The last element, that means C33, will be GL plus HO plus IR. This is the method by which matrix multiplication is done. Here you see a 3 by 3 matrix being multiplied. As I told you, 1 will be multiplied by 1 plus 1 into 2 plus 1 into 3. That means you will be getting this element. Secondly, you will be multiplying these three elements by this order. Thirdly, these three elements by this order. Next, these are these three elements of this row. Second, 2 into 1 plus 2 into 2 plus 2 into 3. You're going to get this element. Similarly, this by this by this one, this one. Then comes your third row. This row being multiplied by these elements. Then this one by this, and this one by this. This is this. So here you see this is a 3 by 3 matrix. 3 by 3 matrix means number of rows are 3 and number of columns are 3. These are the rows. That means the horizontal elements written in the horizontal form are the rows, and the elements which are written in the vertical form are the columns. Now, we will now move to Unit 4. This is actually the application of matrices in business and economics. Here we will be discussing about the uses of matrices in business and economics decision making. So what we will be learning over here, as we are aware of that what matrix is, what determinant is, but how it is performed or how it is applied when a problem is given to us, what we are supposed to do. First of all, from the statement, we have to convert that into a matrix representation of data. So we will be studying today about matrix representation of data, market demand and supply equilibrium, national income model, and input output analysis. These all is simply related to matrix application. Now we will see. First of all, we will try to understand what does we mean by matrix presentation of data. Suppose we take up an example. A firm has three factories, F1, F2, F3, and it has four warehouses, W1, W2, W3, and W4. Now, the, it wants to find the minimum per unit transport cost from each factory to each warehouse. Given the cost data in matrix form in the following, find the minimum as well as the maximum unit cost for each factory to transport its product to warehouses. Here you can see we are given this thing in the problem. Warehouses are W1, W2, W3, W4, and your factories are F1, F2, F3. Unit cost is given to us. That means here we can see that this is a 3 by 4 matrix. There are 3 rows and 4 columns, as you can see. These are the 3 rows. and these are the four columns. Now we have to find what we are supposed to find. We have to find per unit cost is minimum from F1, F2, F3 to W4, W2, W1. How? And per unit maximum cost from F1, F2, F3 is to W1, W3, W2. Now the thing is that how we can find it. We can find it by simply by looking at the numbers as from F1 to W1 it takes 15 rupees, from F1 to W2 it takes 17, from F1 to W3 20, F1 to W4 12. So you have to find the minimum number. Here in this problem we are just presenting, we are not solving anything, we are just presenting this data into this form. That's it. Because here it is a basic application how the numbers are formed or the relation is developed between factories and warehouses. So simply looking at the number, we can write out that the cost is minimum for F1 to W4, F2 to W2. That is simply by looking at the problem. Here, in an allocation contest, a participant can speak either of the five languages, that is Hindi, English, Punjabi, Gujarati, and Tamil. We have five categories of languages. We have three colleges, say college 1, 2, 3, and the respective data is given to us. That our college sends 30 students, of which 10 offered to speak in Hindi. So we will start with college 1, Hindi. First of all, we will write three colleges over here and we will write five languages over here. Now, from this, we will be allocating this information in the matrix form. That means straight away it says that from college 1, we will they are sending 30 students. Now 30 students will be divided among the five languages. So 10 offered Hindi. So straight away in column of Hindi we will write 10. 9 in English we will write 9 over here. 6 in Punjabi, 6 will over here. 3 Gujarati, 3 over here, and rest in Tamil. So that means we will be adding up and subtracting this number from 30. So we will get 2. Secondly, another college 2 sends 25 students, out of which 7 spoke in Hindi, 8 in English, 10 in Punjabi. That's it. We are this is 25. So numbers are over. That means there was no one for Gujarati and Tamil. Third one is they sent 22 students from the third college. That means 5, 12 offered Hindi, 5 English, and 5 Gujarati. Sum is 22. Write the information given above in matrix. So you have straight away written up in the. That means this statement, whole of the statement, has been converted into a matrix form. Now we see another problem. A finance company has offices located in every division, every district, and every taluka in a certain state in India. Assume that there are 5 divisions, 30 districts, 200 talukas in each state. Each office has one head clerk, one cashier, one clerk, one PM. A divisional office has, in addition, an office superintendent, two clerks, one typist, and one PM. A district office has, in addition, one clerk, one PM, and the basic monthly salaries are given in this form. That means an office superintendent will get 15,000, head clerk will get 12,000, cashier 11,750, clerks 11,500, typists 11,500, and PMs will get 7,500. Now, what is the question? Using matrix notations, find the number of posts of each kind in all the offices under offices taken together. Secondly, the total basic monthly salary bill of each kind of office. And the third one is the total basic monthly salary bill of all the office taken together. We can see over here, this statement has been given to us. You can see different type of information is given to us, and we are being asked to calculate the total number of posts. Number one. Number two, total basic monthly salary of each kind of office. And third one is total basic monthly salary bill of all the offices taken together. That means if we apply some logic, that means if we talk about the total bill to be formed, that means simple mathematical calculation has to be done that how many staff members are there and what is their basic salary per month. If we are going to multiply the number of staff by the respective salary and we are going to add up all, so we will be getting the total basic monthly salary bill of all the offices taken together. Now, how to convert this information into metrics? So first of all, what we will do, we will have three offices, number of offices. They will be arranged in row. Divisions are 5, districts are 30, and talukas are 200. This information is given to us in the problem. Second part comes staff allocation in these three different divisions. As given in the problem, we have one office superintendent in a division. I'm talking initially about the division. One office superintendent, one head clerk, one cashier, one typist, three clerks, and two PMs. This was for your division office. For district office, we have 01102, and for our taluka office, we have 011,011. This information has been provided to us in the problem. Now, the third one is, if you go back to the problem, you see this is the order by which the monthly wages were given to us 1, 2, 3, 4, 5, 6. The order will remain the same. You can see over here. Order is the same for office superintendent, for head clerk, for cashier, for typist, for clerk, and for the PM. This information was given to us in the problem. Now, whatever the information what was given to us has been transformed into a matrix. That means we have over here three matrices A, B, and D. Now, what we are supposed to find? Total number of posts of each kind in all the offices are in the column of the matrix A. That means we are multiplying offices by number of employees or the number of the posts designated to each office. We are going to get 5, 235, 235, 5, 275, 270. Your question will be how I got this. This is a simple case for the multiplication of matrix. In matrix A, we have a matrix of 1 by 3, and in B, we have 3 by 6. So we are going to get 1 by 6 as the answer. You can see over here. One row and 6 columns. Now how this 5 came? 5 into 1 is 5. 30 into 0 is 0. 200 is into 0 is 0. That means we are going to get 5. Similarly, we are going to multiply these three elements with this. So 5 plus 30 is 30 plus 30, 200 is 235. This is 235. Third one, same, again 235. Fourth one is same as 5. Fifth one, 1 into 5 is 15. 15 plus 20 into 2 is 60. 15 plus 16. 15 plus 60 is 75. 75, 200 into 1 is 200. 200 plus 2 plus 75 is 275. And similarly for the last one, we will get 270. Now, we have to find the total basic monthly bill of each kind of office in the alley. That means we are going to multiply this by the wages. So we will get 1 by 3. This is 3 by 1. Now we have to calculate the total bill of the offices of each alley. That means what we are going to do, these are the number of posts and this is the amount. This is 1 by 3 and this is 3 by 1. So your answer will be 1. That means we will be multiplying this 5 by 99750 plus 30 into 61750 plus 200 into 42750. We are going to get a single element. This is the element. This is how matrix multiplication is performed and how the data is transformed into a matrix calculative form. Now, we move up to another thing, the different concepts of matrices or the multiplication in your economics part. We will start with market demand and supply equilibrium. It is seen in microeconomics that the demand for a commodity and its supply are expressed as functions of its own price only. The resultant equilibrium of such a relation is given by the equality between demand and supply equation. Here we can see that if demand and supply curves for car are given by this, T is for demand, T is equal to 100 minus 60, and your supply is 28 plus 3, where P is the price of the cars. Then we have to calculate what is the quantity of car bought and sold at equilibrium. That means for equilibrium position, demand and supply must be equal. So straight away, what we are going to do, we are going to equate D equal to S. That means 100 minus 6P will be equal to 28 plus 3P. We will be bringing this 28 on the left side and we will be sending 6P on the right side. That will become 72 divided by 90. That means we are going to get price of the car as A. So we have calculated the equivalent price. That means P is equal to it. Straight away, we are going to substitute this value in S. S will be 28 plus 3 into 8. That becomes 28 plus 24, which is 52. That means we can say that equilibrium price is 8 and the equilibrium quantity is 50.
Excuse me, sir.
Yeah,
Your screen is not visible enough. You are not seeing clearly.
my screen is not visible. Here it is showing
Yeah,
that I'm sharing my screen. Now it is visible to you.
yeah, it's visible, but it's not clear.
It's not clear.
Yes, sir.
Now it is visible.
I'm not quite sure, sir.
You can't see my screen.
Yes, it's
Uh,
blurry.
excuse sir, but mine is clear here, sir.
That means there is some problem with your system.
Okay, sir, let me check.
Now we will take another problem. We consider a two commodity X and Y market model, which is given by demand equations. That means demand of quantity X, commodity X, and demand of commodity Y. So here it is the relation 11 minus 2px plus py, and for dy it is 8 plus px minus py. And your supply equations will be in terms of S and P. Sx is equal to 1 plus 3px, and Sy is 6 plus py, where dx and dy are the quantity demanded for x and y. Sx and Sy is the demand quantity supplied of x and y, and px and py are the prices of x and y. Now, we have to find the equilibrium prices and quantity. For equilibrium for condition x, dx is equal to sx is equal to qx. That means demand will be equal to supply, and supply will be equal to quantity. So we will be taking two equations at a time. 11 minus 2px plus py equal to 1 plus 3px. We will be bringing all the terms of px and py on the left side of the equation and the numbers on the right side. We will get 5px minus py equal to 10. This may be marked as equation number 1. Now we will be considering dy equal to dx is equal to qy. Similarly, we will write p8 plus px minus py equal to 6 plus py, which will be minus px plus 2py equal to 2. Now we can see over here that we have two equations, equation number 1 and equation number 2. We will pick up the coefficients. Coefficient of px in equation 1 is 5, and the coefficient of px in equation 2 is minus 1, and the coefficient of py in equation 1 is minus 1, and coefficient of py in equation 2 is 2. That means it is a 2 by 2 matrix. Here you can see we have two prices px and py, and on the right side of the equation we have two constant numbers 10 and 2. So this is how this is written. Now the thing is that here you can see that there are two matrices being multiplied together, and it is equal to a matrix the same order. When we are going to multiply these two matrices, so you can see this is a 2 by 2 matrix, and this is a 2 by 1 matrix. So your answer will be a 2 by 1 matrix only. But when you are supposed to find the value of px and py, when the equations are in this form, so we have to transform this matrix to this side. In that case, we have to find the inverse of this matrix. If you remember, I have told you how to find the matrix, because this is a 2 by 2 matrix. For finding up the matrix, inverse of the matrix, we have to remember a formula, adjoint of A divided by mod of A. We have a matrix of this 5 minus 1 and 2. We will first of all we will find its mod value. That means we will be solving this. We will be multiplying 5 by 2 minus minus 1 into minus 1, that is 10 minus 1 is 9. Now If we talk about the adjoint, we have to first of all find out the cofactors. Then we have to transform them and we will get your adjoint. This is the adjoint. 2, 1, 1, 5. We will place over here. This is the A inverse. A inverse is 1 upon 9 into 2115. We are supposed to find out the value of this Px and Py. So we will be substituting this by this. Here you can see this has been substituted by 1 by 9 into 2115 being multiplied by 10 2. As I told you, this is a 2 by 2 matrix and this is a 2 by 1 matrix. So its product will be a 2 by 1 matrix. What we are going to do? We are going to multiply this 2 into 10, 20, 20 plus 1 into 2 is 2. 20 plus 2 is 22 and 22 divided by 9 is 2.4. Similarly, we will be doing this 1 into 10 plus 5 into 2. So that means 10 plus 10 is 20. 20 divided by 2 is 2.22. So that means we can say that Px is 2.42 and Py is 2.2. Similarly, by putting up the values, we can find out Qx as 8.38 and Qy as 8.2. Now, the second model is your national income model. Here, we will consider a simple two equation national income model for an economy, ignoring government and trade relationships with external countries in the present analysis. We will be taking up the simple conditions to understand what is the application of matrix in economics. So we have two standard equations. That means y is equal to c plus I naught and c equal to a plus by, where y is the national income, c is the consumption, I naught is autonomous investment, and a and b are constants. As we have discussed for these two equations, y is equal to c plus I naught. This equation shows that total value of national income is seen from expenditure approach. That is, the total expenditure of the economy incurred on goods and services is equal to consumption expenditure and investment expenditure. That means y is equal to c plus I naught. Secondly, we have c is equal to a plus by. Here, this is again a linear relationship between income and consumption. In the present context, A is the interceptor of the linear line assumed to be greater than 0, and it is generally postulated that consumption remains positive even when there is no income. The slope coefficient B is taken to be greater than 0 but less than 1, as general psychological tendency of human being is to consume less than the total income. No doubt, if you have 500 rupees with you, then you won't be consuming all 500. You will be saving something for the future. Similarly, over here, we will we are talking about in terms of a line. The line will remain always inclined. It can neither be perpendicular or it can neither be in horizontal. Now, we have two equations. Y is equal to c plus I naught and c is equal to a plus by. Here we can see that it was told to you that a and b are constants. And income is again a constant. But y and c are variables. what we will be doing? We will be transforming these equations in the form y is minus c is equal to I naught. I naught is in the income. And second equation, what we are going to do? Minus by plus c equal to a. That means on the right side of the equation, we have all the constants. And on the left hand side, in the same order of y and c, we have variables on the left side. So when we are going to transform this into a matrix form, we will be picking up the coefficient of y. Coefficient of y is 1, and the coefficient of c is minus 1. And the coefficient of y in equation number 2 is minus b, and the coefficient of c in equation number 2 is 1. We have two variables, y and c, and we on the right side we have having two terms, two equations. That means we will be having two terms, and these two terms will be written in the form of column. That means I naught a. What we did, what we performed in our previous problem, that was to find out the value of two variables, y and c. So here again we have two variables, y and c. So we will be transforming this matrix to this side. That means we will be taking up its inverse. Inverse means we will be finding out its mod value, and we will be multiplying that mod value with adjoint of the. We'll see how this again how this is performed. Now straight away we will go to a problem because we have seen the method, and here we will see how this is performed. We have two equations, y is equal to c plus I, where and c is equal to 5 plus 3 by 4y. And it is given in the problem that I is 10. So we are supposed to find out the value of y and c. What we will be doing, we will be simply substituting the value of I in equation number 1. That will become y is equal to c plus 10. As what we did in our previous problem, we took all the variables on the one side and the number on the other side. Here in this case, it will be y minus c equal to 10. Similarly, we will be arranging equation number 2. So we will be placing this y and c terms in the same order in which it is performed in earlier step. That means it will become minus 3 by 4y minus 3 by 4y plus c equal to 5. When we will be transforming this into matrix equation, it will be 1. We will be picking up the coefficients. 1, minus 1, minus 3 by 4, and 1. Then, in the second matrix, we will be writing yc, and which will be equal to the third matrix, that is 10 by 5. So we are supposed to get the value of yc. We will just picking this matrix on this side. It will become inverse. Now the thing is that we are applying method number 2. We are not going to apply, we can, but we are not doing here. We are applying Cramer's rule. If you remember, Cramer's rule is we have to find out the value of this matrix, and we have to, when we are going to calculate the value of this y, we have to change, if you remember, we have to change these two elements by these two elements. Here you can see it has been replaced, and the second column will remain the same. It will be divided by the original matrix. So that means you can see over here 10 into 1 is 10, minus 1 into 5, 10 plus 5 is 50. Now when we will be multiplying this 1 minus 3 by 4, it will be 1 by 4. We will be taking this 4 up. The 15 into 4 will be 60. That means y is equal to 60. And similarly, for c, we will be replacing this minus 1 1 by 10 50. Here you see. Denominator will remain the same. The denominator will be 1 by 4, and numerator here it will be 12 by 12.5 divided by 1 by 4, that is 50. That means we can say that Y is 60 and C is 50. Now the third part is input-output analysis. It is another area where matrix algebra becomes handy in the derivation of results. IO analysis is also known as inter-industry analysis, as it explains the interdependence and interrelationship among various industries. For example, in the two-industry model, coal is an input for steel industry, and steel is an input for coal industry, though both are the outputs of respective industries. See the relation, how this economics played a vital role. Now, what are the different assumptions which are taken when we are analyzing IO analysis? The economy is divided into finite number of sectors, that is industries, on the basis of following it. Each industry produces only one homogeneous output. Production of each sector is subject to constant returns to scale. Third one is input requirement per unit of output in each sector remains fixed and constant. And the final demand of the commodities is given from outside the system. The total amount of primary factor, that is the labor, is also given. And we have to consider the labor also. Now the thing is that how this input-output table is formed. Input-output shows the disposition of the total products and total inputs among the different industries. We assume that the economy consists of two producing sectors only. In addition, the production of each sector is being used as input in all the sectors and used for final consumption. Suppose we have X1 and X2 are the total outputs of two sectors. F1 and F2 are the amounts of final demand, consumption for output of these sectors. And Xij is the amount of output of the ith industry used up as the intermediary input by the jth industry. That means Ij will have 1 and 2 values simultaneously. Let L represents the given amount of primary factor. In our assumptions, we already discussed that we have to take labor into consideration also. Here we can see that we have to take the labor factor also. It is the amount of the primary factor. L is the amount of primary factor used in the ith industry. This is how the matrix formation is done. We have producing sector number 1, 2. We have total output of the sector as Xi and X2, X1 and X2. And we have input intermediaries of producing sectors X1, X2. That means it will be in relation of X11, X12, X21, and X22. And finally, in the last column, we will have requirements for final uses. So that is F1, F2. And we have to consider the labor also, or in the respective input, say producing sector, we will have L1 and L2, and your total primary input will be L. That means that total L will be equal to L1 plus L2. It is important to note that the items in the above table are physical unit per unit. Since the entries in any row are to be measured in the same physical units, there is no problem in undertaking addition across the rows. Rows के अंदर हम additions we can do without any problem. The total output column gives output of each commodity and the overall input of the labor. However, items in the same column are not measured in the same unit. So it would not be correct to add down the columns. We will be adding rows. Now, how this model is formed. Suppose it may be seen from the above, but the table what we have drawn discussed that requirement of first industry are recorded in the column, third column X1. Units of the output of the first industry was produced with the use of X11 units of the first good and X21 of the second good and L1 unit of labels. The initial demand, that is column 5, that will be equal to that. X1 will be equal to X11 plus X12 plus F1. X2 will be equal to X21 plus X22 plus F2. And the total labor will be equal to L1 plus 10. If we talk in terms of the summation symbol, so here in equation 1 and 2, we can see that we started with 1. Xi will take up the position, that means in the summation symbol, j equal to 1 and it will take two values to 2. Xij plus Fi. And for L, we have to add up Xi from J1 to 2. Then comes what is meant by Hawkins-Simon condition. This is something very important for calculation purpose. If the IO solution gives negative output, see what is going to happen over here. Then it means that more than one unit of the product is used up in the production of every 1 unit of that product. It is not realistic and such a system is not viable. Hawkins-Simon conditions guards against such evaluations. What are these? For our basic equation, x is equal to 1 minus a inverse into f, not to give negative numbers as a solution, we need to have matrix I minus a such that the determinant of the matrix must always be positive. It should not be 0. It should not be a negative number. Second one, the diagonal elements 1 minus a11, 1 minus a1 minus a22 should be positive. That means diagonal elements have to be positive in all conditions. Or in other words, element 1 1 and 1 2 2 should not less than 1. That means 1 unit of output of any sector should use not more than 1 unit of the own output. This is known as Hawkins-Simon condition. Moreover, the first condition, that is D greater than 0, is applicable over here. The daily cost of operating a hospital is a linear function of the number of inpatients, I, and output patients P, plus a fixed cost A. That means the total cost C is equal to A plus BP, plus DI. We are having a data for 3 days. We have to find the value of ABD, these are the constants, by setting up a system of linear equations and using the matrix inverse. We have cost, we have number of patients, and we have number of output. Straight away, what we are going to do, we are going to place all these in equation C is equal to A plus B, which is applied to 3 equations, that is A plus 10p plus 40i is equal to 6950. Similarly, a plus 9p plus 35i is equal to 6725. Thirdly, a plus 12p plus 401 is equal to 7100. Now, we have three variables, three equations. We have three variables, three equations. Coefficients will be taken. Keep one thing in mind. You have to take the same order of the equations which is given in the problem. If you are going to change any of the order, you won't be in a position to get up a complete answer or the authenticate answer. We have a 3 by 3 matrix and a 3 by 1 matrix. First of all, we have to find the value of ABC. So we will be applying up the formula ABC is equal to A inverse into B. So we have A as 1, 10, 40, 1, 9, 35, 1, 2, 40. You know it how this matrix is solved. Its value is minus 10. Similarly, we have to calculate the adjoint A. First of all, we have to calculate the cofactors. We have to transform them, and by transformation, we are going to get this matrix 60 minus 80, 10, 5, 0, minus 5, minus 3, 2, 1. This is adjoint of A. If we talk in terms of A inverse, A inverse is equal to adjoint of A divided by mod value of A. You have calculated the adjoint A, you have to multiply it by minus 10. That is equal to 1 upon minus 10. This is the matrix. This matrix has to be multiplied by the price. It has to be multiplied by the price. After calculation, get 500, 75, 750, and 75 and 30. That means A has a value of 500, B has 75, and C has 30. Now, this is one of most interesting topic, that is Unit 5, which is mathematical functions. We have heard of many mathematical functions, but we have never thought of it. Why it is given in this form. A function relates an input or argument to an output. Notice the three main components, that is input, relation, and output, presents in describing a function. For example, in producing an output, you have used an input, and may so happen that you have not the input value is doubled the value of the input. That means the relationship between input and output is a simple function of multiplying input into 2, which is equal to output. The term L, small l, or any other letter like G, no, here you can see that a normal function is written in the form of fx. F is function name, x is the input, and x square is what we get as an output. Straight away we can say that x fx is equal to x square. Now, functions and their types. Some important functions find application in economics and business. Now, what is basically meant by function? The function relates each element of a set with exactly one element of another set. In defining the function as above, we know to note the following: that each element implies every element in set, say X, is related to same element of another set in Y. Exactly one implies that a function is single valued. That means f3 is equal to 8 or 9. It's not right. It will have either 8 or 9, but it cannot have two values. If a relationship does not follow these two rules, then it is not a function, although it is still a relationship. In that event, the elements of both the sets are simply ordered pairs. They are called ordered pairs because the input always comes first and the output second. Here we can see we have a relationship representing x tends to x squared. If we keep x on the left side and y on the right side, these are the two sets. If we have four elements, or five, you can say 0, 1, 3, 4, minus 4. If you are implementing and finding out the square, so 3 will be having 9 as its square, 1 will 1, 0, 0, 4 and minus 4, both will have 16. In the relationship above, we can see that X contains the elements of X and set Y has elements of X squared. It is a function as every element of X is related to Y and no element of X has two or more relationships. Now comes what is meant by domain, codomain, and range. You have seen these two values. Set X is called the domain, which has all the values. Set Y is called the domain, codomain. That means codomain. That means it is representing what we have done in what we have done with elements of set X. The set of elements that gets pointed in Y. The actual values produced by the function is called its range. That means fx is equal to x squared. Now, what are the different commonly used functions? Commonly used functions are of basically two types: algebraic and transcendental. If we talk about algebraic, we have polynomial and power. If we talk for polynomial, it can be a constant, linear, quadratic, and many more. And if we talk about the power, it is rational, piecewise. And transitional have two functions with it, that is exponential function, and secondly it is logarithmic function. If we talk about function types in terms of algebra, there is a group of functions called algebraic functions, where a function fx satisfies px. That means fx is equal to 0 as a polynomial x and y with integer coefficients. These functions can be constructed using only a finite number of elementary operations, such as plus, minus, multiplications, and divisions. Initially, we will start with polynomial function. A polynomial function is a function which can be written in the form of fx equal to an xn plus an minus 1 xn minus 1. It will move to a1x plus a. Constant functions. A constant function is a linear function for which the group range does not change or matter which member of the domain is used. Linear function, it is a function which has the maximum power of the variable as well. The basic form is a plus bx. Then comes your quadratic function. Quadratic function is a function which has variable has a power of 2. It may have two solutions, maximum of two solutions. It can have no solution, or it can have equal solution, or it can have imaginary solution. Power function. A power function is a function that can be expressed in the form of fx equal to k into x power p, where k and p are real numbers and k is known as coefficient. Then comes your rational function. A rational function is defined by a rational fraction, an algebraic fraction such that both the numerator and denominators are polynomial. Or rather, we can say that anything which can be written in the form of p by q, where q is not equal to 0. Then comes your piecewise function. Piece means from our data, we will be taking small conditions. We have functions that behave differently depending on the input value. That is, it is defined on a sequence of inputs. The absolute value function is given below is an example of piecewise function. That means we have mod of x, which is equal to three conditions. If we have minus x, then the value of x will be less than 0. If we have 0, that means the value of x will be equal to 0. And if we have x plus x, that means x will have all the values greater than 0. That means a basic function has been divided into three functions. That means we have broken the function into three pieces. Then comes your transcendental functions. I said initially that transcendental functions are logarithmic and exponential. Here we can perform the operations of addition, subtraction, multiplication, division, raising to a power, and extracting a root. If we talk about exponential functions, if a is any number such that a is greater than 0 and not equal to 1, then we have an exponential function in the form of fx equal to a raised to the power x, where a is called the base and x be any real
No,
number.
I'm in a
Here a is called the base and x is the
Yeah.
real. Please mute yourself.
Thank you.
Then comes your logarithmic function. A logarithmic function can be written as a function y is equal to log x, which has
Je kaskan ada.
a, b should be x and b should be greater than 0 and b should not be equal to 1, which gives the basic logarithmic function, which is whether y is equal to log of x with base b, or when we are going to convert it into its functional form, it can
Aga wa
also
ina kin sili din.
x is equal to
Ya
by.
cika mantuwa. Ya cika mantuwa. Ya zo so wurin bi mun yi magana da shi. Before da kuma ta samu matsala. Aka zo karɓar
Mr.
kuɗin
Rahman, please
mota.
mute yourself.
Ba na nan. Aka sa receipt. Da na je karɓar receipt din da bitin zan je in biya. Sai aka samu kilashi lokacin sallah ne bari an je in sallah. Kuma sallah sai na gaba. To da na zo gudu ka ƙara samun saɓani. Sai na ba mai shagon nan. Sai na ce in ya zo a basu. Sai wannan ɗayan baƙin da suke aiki da shi. Sai ya zo ya karɓa kuɗin. Da na zo sai ce min ya karɓa. Na tambaye shi ya karɓa shi za a so a samu receipt ba a samu ba. Can ma ba wa
Mr.
receipt.
Rahman, can you hear
Gashi
me?
nan wannan tana shan kwanan nan. Gida na ɗaya daga fili gida na ɗaya na biyu shine gidana. Ya zo ɗaya ya zo biyu na ɗauko mai receipt wannan ɗin. Na ɗauko mai ya ce min na dawo ba shi ba daga nan ɓar me wani ashirin kofa. In wata ya gada
Mr.
ya dole na
Rahman,
biya
can
kuɗin
you
wata.
hear me?
Yeah.
Please mute yourself.
Ah, okay, okay. Ana za ka kai testing nan wai? Ya za ka testing a rana?
Now, going back where we were discussing about logarithmic functions. Actually, these functions are used when we have to multiply very big numbers. To basically understand, we will have an initial introduction to it. Note that when no base is shown, it is understood that it is to the base of 10. Also note that the domain of the logarithmic function is the set of all positive real numbers, and the range is all set of real numbers. We cannot evaluate log minus 2. We can evaluate log. While evaluating logarithmic functions, the base used most often is base 10 and base e. For log base 10, it can be written as log 10, which is known as common logarithm, or straight away we can write as log log. Suppose we have to evaluate log base to 8, which is equal to 3. What does this mean? This means 2 raised to the power 3 is equal to 8. See to it how the transformation is taking place. If we talk of log base 327 is equal to 3, that means this 3 raised to the power 3. 3 3 is 9, 9 3 is 27. And for base log, base 10, 100. Straight away it is 2. That means 10 power 2 is, this is how the transformation takes place. Now we have, as I told you, this log is used for multiplying big numbers. That means we have 7 conditions, or rather we can say that there are 7 properties of logarithmic function. If we are having log in the form of log mn, straight away that is equal to log m plus log n. That means logarithm of product is the sum of logarithms. That means log mn, which was in product, has been split it in 2 terms. That means log n plus log n. If we have log m divided by n, straight away we will be doing log m minus log n. That means logarithm of quotient is the differences of logarithm. If we have log raised to the power of n, there is an error over here. If it is log m raised to the power n, that is equal to n log n. Logarithm of power of a number is the exponent times the logarithm of that number. If we have log base e of e raised to the power x, it will be x. Log base e to e will be what? Log a, log base a1 will be 0, and log base a will be 1. Now this is basically what we have. We will be using somewhere in our mathematics part these 3 properties: log mn, log m by n, and log m raised to the power n. Now we move to inverse and composite functions. Inverse functions are defined as fx equal to y if gy is equal to x. In other words, a function f has an inverse function only if for every y is it in its range, there is only one value of x in its domain for which fx equal to y. The inverse function is unique and is frequently denoted by f raised to the power minus 1. You might have seen as we have done it in matrix inverse. Now, this diagram will better make you understand what is we are talking about. Let f be a function with domain ABC and codomain 1, 2, 3. We have two figures. We have to see that f minus 1 is inverse of the reason is element of map to 3 is f, while 3 map of A is f minus 1. The same is true for the other elements. What you can see, A is to 3, B is to 1, and C is to 2. Just reverse it. 1 to B, 2 to C, and 3 to A. One in the same thing, no change. That means its inverse exists, and its inverse is f minus 1. We will see to another example to make you understand algebraically. Here you see, we have to find the inverse of this function. Fx is equal to x upon x plus y. Nothing. We will replace fx by y. Y is equal to x upon x plus y. We will solve the problem in terms of x. So we will be taking all x on one side and all y's on the other side. On solving, we will see that x is equal to y upon 1 minus y. F inverse is x upon 1 minus x. Same form, only signs are changing. That is the inverse. We have to change fx by y. We have to bring the equation in terms of y. The basic problem was in terms of x. For finding out the inverse, we have to convert that equation into in terms of y. Now, composite function. A composite function implies applying one function to the result of another. That is, the result of fx is sent through dx and is written as gof, fx, which means fx. Suppose we have a function fx equal to 2x plus 3 and gx equal to minus x squared plus 5. We have to find fog, f or g of x. Straight away, what we will be doing? We will be picking up f, this function, and we will be replacing this x by this. That means it will become 2 into minus x squared plus 5 plus 3. Here you can see 2 into minus x squared plus 5 plus 3. Open it up, minus 2x squared plus 10 plus 3. That means minus 2x plus 2x squared plus 30. That is its form. This is what the composite function is. Now we move to Cartesian coordinates. Function in terms of Cartesian coordinates. For a better understanding of the functional relationship between the variables, let us return to Cartesian coordinate system that is composed of horizontal line and a vertical line perpendicular to each other. Remember that these lines are called coordinate axes. And the point where these two lines intersect is the origin. Now, the distance of a point from the horizontal axis or x-axis is called its coordinate. Please remember it. The distance of a point from horizontal axis or x-axis is known as coordinate. And the distance measured from vertical axis, that is y-axis, is known as abscissa. Coordinate and abscissa. Distance from x-axis is coordinate and distance from y-axis is abscissa. Here you can see. On the right side, that means this is the first quadrant. Here both x as well as y are positive. When we move to the second quadrant on the left side, left part of this, here x is -1 and y is plus. In the third column, that is third quadrant, here x is minus, y is minus. So here you can see. And in the fourth, x is plus, but y is minus. Here it is. Straight away looking at up the coordinate system, you can find it out. What is the actual position of that particular point in all these four quadrants? Now, graph. As we are aware of that, line is a graph of a linear function. If we have a linear function y is equal to ax plus b, it will be a straight line. It won't be bending or it won't be having any curve throughout. If we have, now the thing is that where it is applied. To see the graph of a linear function, consider depicting the relationship between price and the market demand for the commodity, which is often depicted by a straight line. Price increases, demand increases, or it comes down. It's a straight line. Then comes your absolute function. Whatever be the value of x, it will always have a positive value. That is why it is placed up in two vertical lines, mod of x, what is known as mod of x or modulus of x. Whatever the value of x, its answer will be a positive. Suppose we have -1, its answer will be 1. And if we have 1, it will have, its answer will be 1. And if we have 0, its answer will be a 0. Here you can see. Whatever the value you are going to take, it will come to be a positive value. And we are aware of that positive x is over here. Similarly, we are going to get corresponding y. And here -1, we are going to get +1. -2, +2. -3, +2. It all and 0, 0. That means it will be a line which is equally inclined to both the axes. Then comes your step function. We have a little while ago we have discussed about the piece functions. Then comes the step function. It is a staircase type or a piecewise function containing all constant pieces. The constant pieces are observed across the adjacent intervals of the function as they change value from one interval to the next. A step function is a discontinuous function. Features of step functions are open circle or closed circles or the graphs. Point not on graphs, closed not on the graph. It's not a continuous function. It is has horizontal pieces, discontinuous, may or may not be a function, or domain are all reals, and ranges are all integers. Y-intercept 0, x-intercept is 0. Here we see. This is a function. There are 3 steps. Fx -3 when x is less than 2. Fx is getting a value of 0 when it is having a value between -2 and 1. 3 when x is greater than 1. So we are going to depict this in this form. -3 is over here. All values greater than 2. Move this side. For 0, we have to move to 1. 3 to 2. This is step 1. Then comes the graph of functions which have curvy type graphs. Basic first one is quadratic function. A quadratic function, if you remember, quadratic function is denoted by ax square plus bx plus c. Ax square plus bx plus c is a quadratic function. Now the thing is that we have to remember one thing, that a should not be 0. If A is 0, this will become a linear function. That means A should have a value. The graph of a quadratic equation is a parabola and always a parabola. Now, depending upon the value of A, that means its sign, we depict the nature of the parabola, whether it will be opening upwards or it will be opening downwards. If we have A greater than 0, we will always have a parabola with like this line, a proper U. And if A is less than 0, it will be a parabola like inverted U. Now the thing is that computation of the vertex. Vertex x is this point where it turns. Here, this is the vertex where it turns to the other side. We have a formula. Vertex will be is denoted by hx. Your this is the function ax square plus bx plus c. Your vertex h is minus b by 2a. And for calculating this k, you have to put this value into this equation. You will get a value of k. That means you will straight away get your answer in terms of h and k. And h and k will depict this point where this parabola is going to move. Then comes your cubic function. Cubic function, that means a function which has the power of the variable as 3. In quadratic, it is 2. In linear, it is 1. Normal form of quadratic function is ax cubed plus bx plus cx plus d. Another thing is that what will be the nature of its graph? If we talk in simple terms, ax cubed is a cubic function, so its graph will be y is equal to x cube is a function, so its graph will be something like this. Now the straight away question arises, how come? If we take the value of x0, if we take the value of x0, put up over here, y will be 0. If you take x equal to 1, 1 power 3 is 1, so your y will be 1. And if you take x is equal to minus 1, it's minus 1 raised to the power 3 will be minus 1, so it will come over here. If you take 2, it will come 8. And if you take 2 minus 2, it will take minus 8. This is something like, for linear equation, it is a straight line. For quadratic equation, it is a parabola. And for the third cubic function, it is a graph which is something like. Now, we will be talking about different functions which are related to business and economics. Business is basically what we talk about: demand, price, supply, quantity. So how these are depicted in mathematical form. A demand function. Demand is a function of price. For each price level of a goods, there is a corresponding quantity demanded that consumers will demand. If P is the price per unit and X is the demand of the goods, then demand function can be written as X equal to F, where X is the dependent variable and P is the independent variable. Here X and P are positive because negative prices and quantity are meaningless. Normally there is a negative and linear relation between price and demand. Then comes your supply function. Supply is a function of price. For each price level of a goods, there is a corresponding quantity supplied by a producer. If P is the price per unit and X is the supply of a good, then supply functions can be written as x is equal to GP, where P is independent variable and x is a dependent variable. X and P have positive values because its negative price and quantity are meaningless. Normally, there is a positive linear relation between price and supply. Then comes your cost function. The total cost is the sum of fixed cost and variable cost. Fixed cost is the sum of all costs that is independent of the level of output. For example, rent, salaries of permanent workers, etc. Variable cost is dependent on the output. It increases with the increase in our output and vice versa. For example, raw materials, salaries of temporary workers, etc. Revenue function, straight away, what is meant by revenue? It is the product of price and unit sold. That means your revenue function shows the relationship between price of the commodity and the output of the unit sold. If X is the unit, X units of the output are sold at price P per unit, then the total revenue will be product of XP. Then comes your profit function. Profit function is derived by considering profit, funds, and prices of input and output. If Rx and Cx be the total revenue and total cost function respectively, then profit will be revenue minus profit, where Px is the profit and X is the units of the number of the output. The point where revenue from sales is equal to the cost of production is called break-even point, and that point is where we have no profit, no loss. You have to be very clear. A point where revenue from the sales is equal to the cost of production. That point is known as break-even point. Or in other words, we can say that at that point we don't have any profit and we don't have any loss. Or we can say that profit. That means total revenue is equal to total cost. Now, to make you understand what I have been telling you, a businessman sells 2000 items per month at a price of rupees 10. It is estimated that monthly sales will increase by 250 items for each rupees 0.25 reduction in price. Find the demand function corresponding to its estimate. Now, first of all, when a problem is given to us, what we will do? We will break this. We have number of units 2000. We have a price of rupees 10. Now the thing is that it is estimated that with an increase by 250 items for each of rupees 0.25 reduction in price. Okay. Now the thing is that how to derive an equation for it. We have increase in 250 units each time drops of 0.25 from the origin cost of rupees 10. The price will reduce 10 to P. That means it will be 10 minus P. And what is the rate by which it is decreasing? That is 0.25. That means it will be 2000 plus 10 minus P divided by 0.25. On calculating it, we will be getting 1200 minus 1000 P. And we have to calculate the demand function corresponding to this estimate. So we have to calculate the price. Price is equal to 12 minus x upon 1000. Now, this is a problem to be understood very whatever we have discussed till now. The whole thing now has been brought into a terms of a problem. A firm wants to launch a new product. It observes that the fixed cost of the new product is rupees 35,000 and the variable cost per unit is rupees 500. The revenue function of the new product is 5,000x minus 100x. You have to calculate the profit break-even value and the value of x results in loss. Now, nothing to worry. Don't see to the problem solution right now. What we are given, we are talking about launching of a new product. Here is the problem: a fixed cost is available to us, and a variable cost has been given. Going back, what we have discussed, the total cost is a combination of, or it is a summation of fixed cost plus variable. That means here in this particular problem, we have a fixed cost of 35,000 and the variable cost is 500 per unit. Suppose we say that we are producing number of units X, so your variable cost will be 500x. That means the total cost function will become 35,000 plus 500x. First line has been solved. Now we move to second line. The revenue function of the new product is 5,000x minus 100x square. Okay, you have a cost function, you have a revenue. You have to find profit. Profit is calculated by revenue minus cost. Straight away, nothing to do with it. Straight away, put up the values of revenue. That is 5,000x minus 100x square minus 35,000 plus 500x. So we get minus 100x square plus 4,500x minus 35,000. This is the profit. Now, break even value. Break even value is that value where the profit is Ex is equal to 0. So we will be equating this minus 100x square plus 4,500x minus 35,000 equal to 0. Straight away simplify it, remove all zeros. You will be left with x square minus 45x plus 350. This is a quadratic equation. For simplifying or to factorizing this quadratic equation, we have to split it into two terms. Here in this case, we will be getting x minus 10 multiplied by x minus 35 equal to 0. That means x minus 10 is equal to 0 or x minus 35 equal to 0. That means we have a value of x at 10 or 35. That means we can say that according to this problem, whatever the condition is given in this problem, if a company is going to produce 10 units, it will be having no profit, no loss. And if again 35 units, in that case also, it won't be having no profit, no loss. Now that the third part is the value of x results in loss. That means if it is loss, that means px should be less than 0. We will be equating that. For the loss, we have 10 and 35. Loss is possible when x is less than 10 and x is greater. These are the two conditions where we can have it. This is how a particular problem related to profit loss break even is evaluated. Repeating, total cost function is a summation of fixed cost plus variable. Remember that all the things will be given to you in the problem. You have to simply remember the basic formulas. Cost function, profit, break-even point, and its value. Now we move to unit 6, that is limits and continuum. Now the thing is that how this idea of limits of function came. The idea behind limit is to analyze the value that the function is approaching when its input approaches a specific value. To appreciate underlying area, see the following graph. You see this point. There is a green graph, a curve, and there is a point which is marked at 0 and it's depicted by an arrow. We have similar values along the x-axis and along the y-axis. Here you can see that, going back to the graph, you can see that as the value of A is changing, that means it is coming from this to this. That means it is coming down. Value of A is coming down. You can see the graph is approaching downwards. And after approaching a particular value, if you are moving on the right side, it is coming steeper down. Now, what does this mean? We always say that we find out a value graphically. We won't be doing any graphical representation over here, but to make you understand what does this mean, we always say that it is approaching A, but it is not equal to A. You can see that it has approached a value of A. But for that limit, for that function, the y has a value at L. If we see to the point AL, you can see that there is number of points which are on this curve. Now we have to restrict these. This is, we cannot work out the exact value of the function, but we can see that it should be as we get closer and closer. Such a situation is expressed as limit x tends to a fx is equal to a. Or other words, you can say that just replace the value of x, that is in fx, by a. That means you're going to get a number. Now, what actually this limit means? Now we take up an example of fx equal to x squared minus 1 upon x minus, and we will try to solve it by putting x equal to 1. Straight away, when you are going to place x equal to 1, you are going to get 0, and 0 does not solve it. And I'm telling you, its answer will not be 0. Then if its answer is not 0, then what is its answer and how to get the solution? We take two parts, one on the left and one on the right. That means one on the left means a negative value and one on the right means a positive value. We start with a positive value of 0.5 and we start increasing a little bit till 0.9999. We are not approaching. When you are going to place up these values, you will see that you are approaching a value of 1.99 when your value of x is 0.99. When your value of x was 0.5, you got 1.5. Or in other words, you can say that when you are moving from 0.5 to 0.99, the value of the function is increasing from 1.5 to 1.9. Then comes your continuous function. Okay, simple as the word suggests. A continuous function is that function which the graph of it does not break anywhere. Continuous function is a function in which the graph does not break anywhere. Or we can say that a small change in its value will simultaneously show a small change in its output. Then comes your limit of a function. Mathematically, it is, or symbolically, it is written as limit x tends to c, fx equal to L. This is how it is pronounced. Or we can say that x is approaching c, but is not equal to c. That means an approximate value. Approximate is approaching c, but it is not c. To find out the limit, we need to work on the values of the function for two different values of x. One on the left side and one on other one on the right. What we see that? How it is written on mathematical. Limit on the right side is represented as c plus. Limit on the left side is written as c negative. And the limit at that value, c, is written as c. We are going to get three values. L, L, L. Here we see that all the three values are equal. If it is so, we can say that the limit value is x. We are given a function x square where x tends to 2. What we will be doing? We will be taking two values of x. One less than 2 and the another one greater than. If we take less than 2, it is 1, 1.4, 1.7, 1.8, 1.9, 1.99, 1.995, and 1.999. Placing up the value, squaring it, you are going to see that it is changing its value from 1 to 3.996. And when we are taking values greater than 2, 3, 2.6, 2.4, 2.1, 2.1, 2.01, 2.005, 2.001, you see that you're getting a value of 4, 4.004. And at the top, you are getting 3.996. That means it is equal to 4. Your limit on the left side is 4, and on the right hand side, it is 4. Simply. Now, to make you understand how the problems related to limit are solved, this is a very basic problem to make you understand. This is the problem. Limit x tends to 1. Your function is x squared minus 1 upon x minus 1. Straight away, when you are going to put up the value of x equal to 1 in this function, it will become 0. 0 is meaningless in limits. What we are going to do? We are going to split this up. This is a square minus b square. A square minus b square is a minus b into a plus b. This has been transformed. And from this x minus 1 and this x minus 1 gets cancelled. You are left with x plus 1. When you will be applying limit x tends to 1 to this function, you will get an answer of 2. Earlier, by putting up the value of x equal to 1, you are getting 0. Now, by simplifying it, you are getting 2. With this, I will be stopping the presentation. Now, just let me know what you have understood. We have a discussion on matrix. We have a discussion on application of matrix in business, and we have started limits. What you have understood. And initially, we started with the multiplication of matrix, which is one of the most important parts. Any question from anyone?
Yes, no,
Yeah,
mine is not a question rather,
yeah.
but you know, for me, mathematics is a bit difficult for me to understand. But I believe when I go through this your lectures later, I'll be able to understand better. And if I have any question in our subsequent class, I may raise
I
them.
request.
But for now, I don't have any
Listen.
questions.
It is but because the thing is that I'm teaching you in the very lucid manner. The thing is that my purpose is to make you understand what all these topics are and how it is applied. Now the thing is that I request everyone to work upon, to go through the video, write it with your own hand, listen to the conversation, and it will be easier for you to understand. I request everyone
Thank you so much, man.
to
I
go through
will
the
do that,
study
sir.
material as well as to the video and be present in the class. It will be beneficial to all of you. I don't know how many of you are good in mathematics, but still, it's not that mathematics, it is applicative and easier to understand mathematics. Some of you might have listened to some of the terms and what I'm using over here, and in our next classes also, we will be discussing the same things, but you might be aware of some terms, but have to go through the subject once of your own also. Anyone else?
Sabi, I want to say something.
Yeah.
I actually enjoy your class because I do understand it. But today, the dashboard, I don't know if it's only mine that was having a problem. It will show then, after sometimes it will go blank, then it will show again. So I don't know, it was making me, I was lost and I was confused.
I didn't got you what you mean to say. Can you write your query in the message box?
Sorry, sir, come again.
Just write your query in the message
Excuse
box.
me.
Yeah,
I think what she means is that there are times when her screen will go off and it will come back again, meaning the visibility of your screen, sir, is not clear at times. That's what she's trying to say, sir. The
okay,
screen is not clear at times. Yeah, in the process of the lecture, sir.
okay. That maybe might be due to the um, fluctuation in the signals. Might be a reason.
Okay, sir. Thank you.
Okay, so with this, I will be concluding today's session, and we will be meeting with meeting everyone in the next session on next Friday. And I request everyone to go to the study material because we will be doing limits, differentiality, and continuity in our next class. Okay, thank you. Bye bye.
Okay, thank you, sir. Bye bye.
Hello.
Hey, you people, there's a lot of problem, pa.
Hello, Abdul.
Wallahi, there's a lot of hello,
Yeah,
Anas.
name.
How today? Wallahi, normal. How
Oh, we
tomorrow?
thank God. Oh. Eli and others. Kelly, this month we need to really start doing this our discussion. This month is not easy, seriously.
It's, be- it's better, wallahi. Allah, I don't catch anything wallahi in this lecture. In this
Oh,
lecture wallahi.
so it's better. It's better.
I just
It's
be
better we start.
because
It's better we start our discussion. If not, will be having problem with this
I,
mathematics. This be
can I ask you which location you are?
kai ina plateau ne fa ni dan Jos ne kai fa.
Plateau. I am living in Kano. We are so distant.
No ala mi magana ta private wannan kasace muna wani yare. Kelly Alpha.
Don't worry. Okay. Hello, Kelly. Is there anybody?
Mu koma WhatsApp platform kawai mu yi magana da kai. Abdul,
Ba matsala. Don't worry.
mu yi magana ta WhatsApp platform.
Na?
Mu yi magana ta WhatsApp kawai.
Ba matsala.
Kaji wani.
Yayi zabi. Zabi, bran katsewa.